Hi guys, I hope you guys are having fun at home. We're having a little fun today at the Clay Center. Missing you guys and hoping to get to see you soon. Today we are playing with a little bit of pH. Now, you guys might have heard that word before, pH, but what does it mean, right? So most of us are familiar with pH because of the pH scale. So there is a scale that kind of tells us certain substances and how acidic or basic that they are, alkaline. So on the pH scale, acids are sort of lower numbers. The pH scale runs from 0 to 15, and the acids on the scale are anywhere from 0 to 6, and then you have and acids are things like lemons, vinegar, battery acid, stomach acid, those kind of things. And then you have neutrals, which are like pure water right in the middle, and that's a 7. And then you have substances that are basic or alkaline, and those are things like drain cleaner or ammonia or baking soda. So some common household things fall on that pH scale. And today we are going to have a little bit of fun showing you some of the cool tricks you can do with the magic of pH. So I have a clear liquid here, and you guys are going to be my junior scientists. The coolest thing about science is just making observations and doing investigations using your observation skills. So just to review what observation skills are, that's just using your 5 senses to learn about the world around you. So we make observations all day long, whether we know it or not. We hear things, we see things, we taste and smell things, we touch things. So we're learning all the time about things that are happening all around us. So today we're going to make some observations using our sense of sight to watch this experiment unfold. So I have a round bottom flask here, and it's full of a clear liquid. And I have a smaller round bottom flask here that's full of another clear liquid. And I'm just going to use my pipette, and I'm going to mix one clear liquid with another clear liquid. Now here's a question. What typically happens when you mix one clear liquid with another clear liquid? You get a mixture of clear liquids, right? Yeah, all right, that makes sense. So let's find out what happens when I mix this little clear liquid in with the big clear liquid. Here we go. Well, that is different. All right, so this clear liquid made this clear liquid pink. That's interesting. Do you think it was science, or do you think that was magic? Well, we'll find out. Stay tuned. All right, so to finish this experiment, we had one color change happen there. Now I have my super science-y straw that I'm going to use, and we're going to see if we can make another color change happen. So I'm going to unwrap my straw and place my straw down in my chemical. Now, I know that these are 2 chemicals that I do not want to drink, so for this experiment, I'm going to be blowing air, my air, into this mixture, and you guys are going to use your eyes to watch what happens. All right, here we go. Ready? Do you notice bubbles? There are lots of bubbles. All right, here we go. Ready? What is happening? Are you seeing this? Whoa. All right, so that was definitely a second color change. Again, I'm going to ask you, is my breath magical, or was this science in action? I think it was science, right? Yeah, so let me tell you the secrets behind this trick here, this science experiment. So in this round bottom flask, I had a mixture of water and a pH indicator called phenolphthalein. And when phenolphthalein is mixed with a base, like ammonia, what was in this little container here, ammonia is a typical household cleaner, the phenolphthalein turns like a dark pink color. So that's why when we mixed one clear liquid with another clear liquid, we got a dark pink color. But phenolphthalein in the presence of an acid turns back to clear. So what about my breath is acidic? Does anybody know what primary gas we breathe out when we exhale? If you said oxygen, that is not it. It's carbon dioxide. So we breathe out several gases and water vapor when we exhale, but carbon dioxide is one of the primary gases that we breathe out when we exhale. And when carbon dioxide gas is dissolved in a liquid, then it becomes acidic. So what happened was the carbon dioxide gas from my breath was blown into this chemical mixture, and it turned the liquid in here more acidic than it was basic. So that pink color went from being pink back to clear. And something to note, if you drink soda sometimes, I like a good Coke or Pepsi every now and then. The reason that it's good to make that a sometimes food is because the carbon dioxide in it, which makes it fizzy, also makes it acidic, and that mixed with the sugar in it can make it hard on your teeth and your body. So it's good to have an occasional soda fizzy drink, but you want to definitely make it a sometimes food just for that reason. Just a fun side note you can tell your friends about. All right, guys, that was lots of fun. So now we're going to move on to another pH experiment. Now this one is a mixture between a pH experiment and air pressure experiment. I have a couple of different ingredients here. I have a cup of water. I have some Alka Seltzer tablets. I have a artifact from the past, which is a film container here. Before digital, we had film, and they came in these little containers. But they make great uses for other things. And then I have some just water. Now, Alka Seltzer is typically used as medicine. We put it in water and we drink it, because watch what happens when it is put in water. Are you guys seeing what's happening there? It's making bubbles. And fizzy drinks, when your belly is upset, kind of sometimes helps to settle the upset stomach. So Alka Seltzer is used sometimes to settle your upset stomach, because it bubbles up and makes the drink nice and fizzy. But it also makes great rocket fuel. So today we have our little film canister here, and we have our Alka Seltzer. Now you might be asking, well, what is in the Alka Seltzer tablet that makes it fizz like that? So it's pretty cool. It's pretty much like vinegar and baking soda experiment. Have you guys ever done an experiment where you mix vinegar and baking soda and it kind of bubbles up and it looks like a volcano? Well, Alka Seltzer has some of those similar ingredients. Two of the active ingredients in it are citric acid, which is like the vinegar in the experiment, and it also has sodium bicarbonate, which is like baking soda. So whenever you mix it with water, those chemicals react and it creates those bubbles, just like a vinegar and baking soda experiment. So today we have a little half tablet of Alka Seltzer, and we're going to add some water. Now, what do you think is going to happen when this starts bubbling and I put a cap on the bottle? What do you think might happen if you trap air inside of a closed container? We're going to add our water in, and I can already see those bubbles starting to form. I'm going to close it up, set it down, and step back. And we'll watch what happens. So right now, all of those bubbles are popping and releasing air into the canister. So air pressure is building up into that little teeny tiny space. The tricky thing about this experiment is that you never quite know when it's gonna pop. But you have a pretty sweet rocket when it does. It happens because of the acid and the base creating that chemical reaction, but then we have the air pressure of trapping all those bubbles inside of that little film canister until eventually it just pops. Now, if you have the stuff to do this experiment at home, go for it. The one thing that I say to do is make sure that the adults in your household know that you're doing it. And just like I did, whenever you close in those bubbles, make sure you take a step back. There is nothing more painful than getting whammed in the face with an Alka Seltzer rocket. It does not feel good. So take a step back so you don't accidentally wham yourself in the face with the film canister. All right, guys, I hope you had some fun with pH and air pressure today. We hope to see you soon, and take care.